Hey everybody, we're back and we're doing your second part of section 3, and now we're going to talk about the factor theorem. And the factor theorem says a polynomial f of x has a factor in the form of x minus k. If and only if the value of k in the function f, so we say f of k equals 0. So let's talk about what that would look like in an actual problem, okay? So if I want to show that x minus 2 and x plus 3 are factors of f of x, then we're going to find the remaining factors. So here's what we're going to do first. To show that x minus 2 is a factor of f of x, we know that if this is the factor, the value of k at f of k has to equal 0. So x minus 2, if I'm looking at this value, if we put this in the form of x minus k, we know the value of k is the 2 because it comes after the minus. So we're going to put the 2 here. And then just like when using synthetic division, we're going to take our coefficients, just like we learned today, 2, 7, -4, -27, and -18, and we're going to divide. So we're going to put it in descending order, which already is. So we've got our coefficients 2, 7, -4, -27, and -18. Draw your line. And the first step is we bring down the 2. And just like we learned today, this is instead of plugging in all those values, into these values of x here, here, and here, and here, we're going to use synthetic division. So here we go. We're going to multiply 2 times 2 is 4, goes here, and then we add down. 7 plus 4 is 11, and then we multiply again. 2 times 11 is 22, and then we add down. -4 and 22 is 18, and then we're going to multiply. 2 times 18 is 36. I'm going to add down -27, and 36 is 9. And then we're going to multiply 2 times 9. We get 18, and then we add down, we get 0. This is our remainder. Now check it out. If our value of f of k was 0, which it is, because remember we learned yesterday that by the remainder theorem that we learned yesterday, that if f of 2, but using synthetic division, if the remainder was 0, that is the value. So because this part is true in our factor theorem, then I can say then yes, x minus 2 is a factor of f of x. Okay? Now, once we have that, we can find out here if x plus 3 is a factor. Now, you can divide x plus 3 into the original equation, or you can do something that's going to be easier for us to find the remaining factors, and we're going to use the remaining coefficients to divide to see if x plus 3 is a factor. So again, -3 is going to go in our box because we know x minus -3 is really x plus 3, and that term here is -3. So -3 goes in the box, and then we're going to use our remaining coefficients, which right here in purple are 2, 11, 18, and 9. And now we're going to see by synthetic division if this works. So we bring down 2 and we multiply. -3 times 2 is -6, add it down is 5. -3 times 5 is -15, add it down is 3. -3 times 3 is -9, add it down is 0. So check it out. Our remainder is 0 again. So that means it tells us that x plus 3 is a factor. Now, how can we tell the remaining factors? So here's what you're going to do. I'm going to make some room for me, so I'm going to erase this a little bit. So if I want to know what the remaining factors are, here's the coolest part. This is such a fun thing. Okay, so remember how we talked about what's left on, and I'm going to highlight it here, what's left over in our synthetic division, which in this case is 2, 5, 3, and then here's our remainder 0, right? We knew this is the remainder, and then this is our constant term, this is our x term, and this is our x squared term, and so on. So we know what's here is 2x squared plus 5x plus 3. In order to factor this remaining, we can use any form that we want to factor. We could factor it directly, or we can use the quadratic formula. So you can use whatever you want, but for me, I think we could factor this. So if we remember factoring, I know I see 1, 2, 3 terms here, and I know 2 times 3 is 6, and 5 goes right here. What multiplies to 6 and adds to 5? Remember, well, that's 3 and 2. So we split this up, 3x and 2x. Bring these down, and then we group these. This should be a review of factoring for you. We're going to pull out an x, and we get 2x plus 3. We can't pull anything out of here, so we pull out a 1, and we get 2x plus 3. These match, so we can pull those out as a GCF, 2x plus 3 times x plus 1. And those are our remaining factors. Okay, so those were our leftover factors. We verified x minus 2 and x plus 3 are factors, and then we found the remaining factors by factoring what was left from our two synthetic divisions. All right, then the last one we're going to learn today is the rational root 0, or the rational 0/root test, okay? And here's what it says. If some function f of x, where this is our descending order, what we're really looking at is this coefficient on the highest term and our constant value here, that every rational 0 or root of f has the form of p over q. And what that means, where p are all the factors of a sub 0 right here. I'm going to put this in orange. All the factors of a sub 0, this constant term here, are called p, and all the factors of a sub n, which is the coefficient on this term here, are called q. So let's talk about what that even means. Find all the possible rational roots of f of x equals x cubed plus x plus 3. So again, I'm going to look at my coefficient on my biggest term. We call this q. We look at the coefficient or the constant term here, we call that p. So to list all the possible roots, we're going to take all the factors of p and we're going to put it here, and all the factors of q and we're going to put it here. So here's our factors of p are 3. So factors of 3 are 3 and 1, and remember, factors can also be plus or minus. And all of our factors of q are just 1, so we just say plus or minus 1. Now we're going to combine that, and our list of factors of p over q are going to be plus or minus, and we're going to take 3 and put it over 1. Well, 3 over 1 looks like this, comma, all of our factors here are 1, and we're going to put that over 1. So then we take all of our choices for p and put it over q as well. So we go 1 over 1, plus or minus. So we simplify that, and we get plus or minus 3 over 1 is just plus or minus 3, and plus or minus 1 over 1 is just plus or minus 1. So my choices for all the rational roots are positive 3, negative 3, positive 1, and negative 1 right here. So positive 3 and negative 3, positive 1 and negative 1. And that's my list. Now, they may not all be roots, but that's my list of possible roots. So now we're going to use the rational root 0, the rational 0 test, to find the rational zeros for this f of x. So again, we're going to look for the factors of p over the factors of q. So the factors of 3 are plus or minus 3 and plus or minus 1. The factors of q are plus or minus 2 and plus or minus 1. So to make my list of all factors, we put every value of p over every value of q. So the first one we're going to do is plus or minus 3 over plus or minus 2. The second one we're going to do is plus or minus 3 over plus or minus 1, which is just 3. And then we're going to do plus or minus 1 over plus or minus 2. And then our last one we're going to do is plus or minus 1 over plus or minus 1, which is just 1. So here's our list. So our total list is plus 3 halves over, also negative 3 halves, positive 3, negative 3, positive 1, negative a half, positive 1, minus a half. And so we're looking for the rational zeros. So here's what we're going to have to do. We're going to have to test these roots until we find one that will work. So we're going to use synthetic division to test it. So I'm just going to pick one. I like to pick easier numbers first, so let's pick positive 1. Positive 1 to go first. And then again, using this in our synthetic division, we put our coefficients in descending order. So 2, 3, negative 1, excuse me, negative 8, 3. Draw your line, bring down the 2. And now we're going to multiply. 1 times 2 is 2. Bring it down and add it. And then we're going to go ahead and do it again. 5 times 1 is 5. And then we're going to add it and multiply it again. Negative 3 times 1 is negative 3. And then we're going to bring it down and add it. Now, check this out. We just got a remainder of 0. And if there's a remainder of 0, that tells me that 1 is a root or a factor or a 0. Okay? So we know for sure that 1 is a factor. Now, here's the deal. Now that we've found one of them, what's left over here is our leftover polynomial. This is our constant term, x term, and x squared term. So we're really left with 2x squared plus 5x minus 3. Now, because we know that 1 is a root, I can use what I have left here. I could keep using synthetic division, but I know this is a quadratic. I could keep going and hopefully find one of those 7 leftover factors that will work for us, or I can directly solve it by using the quadratic formula to solve. So basically when we're looking for factors or our roots, we divide until we get it down to a quadratic, and then we just solve directly using the quadratic formula. So here's our quadratic formula. And remember, we're going to plug it into x equals negative b plus or minus square root b squared 4ac all over 2a. And we're going to plug it in. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So we go negative 5 plus or minus the root of 25 minus 4 times 2 is 8 times negative 23 is negative 24. Remember to keep this minus separate at first and do everything else behind it so it doesn't get lost. Over 2 times 2 is 4 in the bottom. Again, minus a negative is really adding the opposite or adding a positive. 25 and 24 is 49. The root of 49 is really 7. So I know negative 5 plus 7 is 2. And then negative 5 minus 7 is negative 12 over 4. And now we can simplify. 2 over 4 is 1/2. Negative 12 over 4 is negative 3. And those are my remaining two zeros. So we would say, for our solutions, we'd say x equals 1/2, negative 3, and then the first one that we found up here was 1. And those are our rational zeros for the f of x that we started with. All right, I'll see you guys back in class.